In this problem, it gives us this molecule, HBrO2. And it asks us to determine the chemical equation of that in an acid-base dissociation circumstance in an aqueous solution. This compound, as you look at it, is obviously going to be an acid. The reason is because it's got that donable or donatable hydrogen. In an aqueous solution, it's going to be added with water, and water is going to become the thing that accepts this hydrogen. So I'm going to have an equilibrium setup where this thing becomes BrO2 minus, it loses its hydrogen, that hydrogen is now gone and gets replaced with a negative charge. This is its conjugate base, and then this thing accepts that hydrogen to become H3O plus, known as hydronium. That is, in all seriousness, the acid-base equilibrium in an aqueous solution for this molecule. However, this is not any of the options in the multiple choice lineup that we're given. So what do? Well, as it turns out, chemists are sometimes lazy and they like to throw water out of there. In other words, we take this molecule HBrO2 and instead we just show the hydrogen being lost and we draw its conjugate base. So this shows the H coming off or dissociating from this acid, and then it shows the release of the conjugate base. This is sort of a lazy way of drawing it, but we chemists often do. In aqueous solution, of course, we understand that this H plus is going to get picked up by an H2O to become H3O plus. This is going to be sort of the simplified, lazy way of writing the equilibrium expression for the dissociation of this acid to form its conjugate base in H plus. What then is going to be the Ka expression of this? Well, the Ka is going to be equal to the individual concentrations of the products, which are going to be H plus, BrO2 minus, divided by the concentration of the reactant. If we were writing a Ka for this reaction up here, we would totally leave water out because water is a liquid, even though I haven't written it. It is a liquid. Liquids do not appear in equilibrium dissociation expressions. So what we would have if we use this one would be BrO2 minus concentration, H3O plus, and then this thing in the basement. As I've already stated a couple of times in some of my videos, H3O plus and H plus are kind of interchangeable. Sometimes H plus is sort of the lazy way of writing H3O plus. But you have to keep in mind that if you throw an H plus into water, it's instantly going to form H3O plus. So that is the answer to this question.